Good morning, everyone, and thank you for taking time out of your busy days to join us today, our webinar on next generation intelligent battery packs. My name is Karen Craig, and I am the regional manager here at our head office in Vancouver, BC. Joining me today is our CEO, Ian Kane, and our Director of Engineering, Mike McQuilly. Just to let you know, we are recording this session so that it can be available to you for later viewing. And also on your screen, you will see a little Q&A button. Please feel free as we go along to type in your questions there, and we will take some time at the end to answer them. Okay, next slide. Our objective today is to share some information about Excell Battery and how we can support a wide range of applications. Our CEO, Ian Kane, will talk a little bit about industry trends in battery pack applications. And then our Director of Engineering, Mike McQuilly, will cover designing with next generation intelligent battery packs. And as well, Mike will cover design and application safety and best practices. And then we will have some time at the end for some Q&A. All right, so let me start by telling you a little bit about Excell Battery. Excell Battery is a leading OEM supplier of industrial and medical battery packs for over 35 years, supporting a wide range of critical applications. Our goal is to provide safe, reliable battery packs that meet demanding ruggedization and high temperature requirements. We are ISO 9001 certified and ISO 1345 certified. Excell Battery custom battery packs are designed to conform to a wide range of unique applications and are supported by the most advanced cell manufacturers in the world. Our teams are best equipped to support our customers early in their development process to ensure that the best fit battery solutions and the best end equipment performance. Properly designed battery packs result in lowering the total cost of ownership due to higher reliability, better performance, and increased safety. Manufacturing redundancy at different locations and in different countries allow us to deliver high-quality products faster and more reliably. Our dedicated engineering and support teams include electrical, mechanical, thermal, and quality experts who will work with your development teams to understand your application requirements and will guide you through your design, safety, and any regulatory requirements. Next slide. We have 4 locations across North America: Vancouver, Calgary, Toronto, and Houston. Each Excell Battery location is fully equipped with test equipment, welders, certified solder personnel, and quality control specialists to ensure high-quality battery packs are delivered every time. So that's a general overview of Excell Battery. And now I will hand it over to our CEO, Ian Kane, who will cover industry trends in battery pack applications.
Thanks, Karen. Great introduction. Good morning, everybody, and thanks for joining us. So I'm going to talk a bit around what are the big drivers around technology in the battery world. And so, what is all the hype around this? So let's jump into this and let's get into a bit of discussion here. So the interesting part about we're all hearing every day, the EV market and expansion and batteries, and it's going to save the world. So there's certainly a huge growth taking place, 32% annual growth. And that's, whether it is in various markets, whether it's EV or grid storage, with different geographies and different chemistries. And so there is this broad expansion taking place, which is driving new technologies. It's driving new technologies in batteries, in battery management systems, and to be honest, across the full life cycle of batteries. And we'll talk a bit more about that. But fundamentally, there is a huge expansion taking place in this market. And it's important for us as users and designers of battery packs and battery solutions to understand where these drivers are coming from and what are the risks behind them so that we can design the optimum solution for all of our customers. So, we just look at this graph and we see the expansion of EVs. It's dramatic. However, at the moment, most of the EV value chain is sitting in China. That's where they make most of the battery packs, the cells, the processing the minerals, etc. So there is that expansion in China. There's no doubt about it. in Europe and the US is behind. However, there's a huge amount of money being put behind this whole renewable world. US has just committed $350 billion to the renewable world. And so that's where you can see in this graph, the US battery renewable world EV market is growing dramatically. And that's also complemented by Europe is also spending a lot of time and money because they realize this is a critical security related energy source that we all have to have a stake in. So this expansion is taking place. This expansion is taking place currently, predominantly in China, but it is now growing in North America and Europe. And so that will drive technology in North America dramatically over the next 10 years. We hear a lot about the EV market and it's growing, and the transport market's certainly growing. However, energy storage is also growing. Stationary systems are becoming more and more prevalent in various applications, and it's predominantly lithium-ion, phosphate, and flow batteries that is the hype at the moment in this stationary world. For example, there's a company called Clean Design that has got CAN containers full of batteries and inverters, and that they use to optimize a generator and reduce emissions, etc. So there's a lot of activity in that market. So that's another part of the driver of technology in the whole battery world. And then we get into the consumer electronics, the industrial part of the expansion taking place. And so that's also dramatically growing, and that's what we'll spend most of our time today discussing. So, and I put this up because I think sometimes it's amazing what goes into various products we have. And if we look at the full value chain of a battery, it goes right from a mine. We've got to refine it. We've got to then get, the anode and cathode and electrolyte material, and has to be high quality, pure. And then we go into, cell manufacturing, pack manufacturing, installed into the device or the vehicle, and then eventually recycling. So it's a very complex life cycle that is entailed around batteries. And I think what we don't often realize is this has all got to build out dramatically based on that information I showed you earlier. This has to build out exponentially over the next 10 years. That, for example, they estimate that we have to increase the amount of mines by 300 to be able to extract the minerals we require. And so you might say, well, why are we worried about that? Well, obviously this whole value chain has an impact on environment, on environmental footprint, on carbon emissions, etc., because all of this is going to use a lot of carbon to produce it. So there's an environmental piece we need to keep in mind when we're thinking about all these elements. But beyond that, we all know that supply chain over the last 3 years has been extremely unstable. And I don't think that's going to change much. And we've learned that, any wobble in the world impacts our supply chain. And we've felt that in the battery world. Trying to source batteries, cells has been hugely difficult over the last 3 years. And part of that is because of this expansion and growth. And we don't necessarily have the minerals and the processing capability and the cell manufacturing capacity, etc., to do it. And if we do have it, maybe they're getting locked down, and there's implications of that. Now, obviously, that'll expand in North America, etc. But with that dramatic growth, there's going to be a challenge in sourcing these batteries and these cells, etc. And, I heard a stat the other day that I think they said by 2030, there will be a huge shortage of copper, which is another element that we use quite often. So at the end of the day, the important piece of this whole value chain is that it is going to be unstable. As we develop new technologies in each part of those value chains, it's going to have a risk to it. And so when we're designing product, we need to realize that we have to consider all the risks of the new technologies required through that value chain, and how can that impact my delivery, and how can it impact my quality of product. Now, what we can see from this graph is that there's a huge amount of different minerals used in a battery, and so that all increases the risk of availability, sourcing, and quality. As we said, new facilities are being built, new technology is being used, and with that comes the risk of technology being appropriate and quality being there. And at the end of the day, they estimate, over the next few years, lithium-ion based batteries are going to be 70% of the rechargeable market. So there's no doubt there's this growth taking place, and it all comes with risks that we as battery users and battery designers need to keep in consideration. So, we ask, so where's all this activity happening? There's a huge amount of development, whether it's environmental, medical, utilities, industrial applications, etc. And so all these different industries are requiring batteries. Just look around your table. You've got a laptop that uses a lithium-ion battery. You've got a cell phone. You've got iPods. All this is requiring more and more lithium-ion type batteries, better technology, longer runtime, reduced cost, increased ESGs. And so all of this is impacting the way we think about how we should design our products and what kind of technology we should use. At the end of the day, one thing that we always learn is that we experience is that your hardware can only take you to one point as it develops, with its size, with its output, etc. However, beyond that, we often go to software, firmware, electronics to optimize our battery packs, to optimize whatever product we have. And so that's where we're shifting these days. We're hitting the limits as far as what chemistry can do for us, as far as lithium-ion is concerned. There will be new chemistries that get developed, but it takes a lot of time for them to be developed, to be bulletproof, and to be accepted by the markets and as safe. So, when you're thinking about what are the technology performance characteristics when you're designing, these are some of the ones that come to mind very quickly. Is energy density, so it becomes lighter, we get more energy out of it. Is power density, how much power can we get out of this, depending on your product. And each component or product we're designing has a specific energy and power requirement. And then there's cost. Now, there's a lot of talk at one stage that costs are coming down as far as batteries or cells are concerned, and I'll show you the next slide shortly what that's looking like. But with all this demand for EV batteries and batteries across the market, that cost is going to start increasing more and more because it's all supply and demand. And as we said, supply is going to be a challenge more and more beyond what we've just seen over the last 2 years. The other piece of it is environmental, and often we forget about, we view batteries as environmentally friendly, but at the end of the day, they've got to be recycled, they've got to be processed. So all that has got to be considered. And even when we make our battery packs, there's going to be environmental impact. So that's got to be considered. And I expect the governments will put more regulations around environmental management of our batteries. And that goes with safety as well. There's more batteries out there. With more battery packs being out there, it means there's higher risk of fires. And we're hearing on a daily basis fires taking place because there's so many batteries out there. And as it expands with the amount of batteries out there, that's going to increase. So safety is going to be very important. And I expect more regulation to come down the pipe around safety of battery packs. And then lifespan. We all want our cell phones to keep its charge. And over time, that charge doesn't retain itself. And so the more and more people are asking for longer life batteries. All of this, some of this, most of this you can impact with chemistry. However, chemistry has a limitation. So battery management systems, battery technology, as far as, hardware, your ICs and your management systems, all will play a huge role going forward to optimize and maximize your battery performance. As I mentioned, costs are were going down. However, over the last couple of years, now we're seeing costs of batteries going up. And I expect that trend to continue going up, partly because of supply and demand is a big piece of this. And, there are new battery chemistries coming out, but they also need minerals like solid state and sodium-ion batteries. These are future technologies, no doubt about it. However, they all require the similar kind of materials, which are going to put a strain on the supply chain at the end of the day. So, to bring this all together, there's a lot of parameters you got to consider when you're designing a battery pack. And there's, so when you got to understand the broader market, what's happening out there. You also got to understand the technologies, and that, chemistries have a limitation. But at the end of the day, a lot of it's going to be driven by intelligent battery management systems, smart artificial intelligence technologies, and all of that is going to drive these various parameters that we all need to consider when we're designing a battery pack. And this will then enable us to get longer life, safer, reduced wastage, less impact on the environment, and at the end of the day, more predictability, safer battery packs. So I'm going to hand you over to Mike McWillie, who's going to give you more detail of, what you have to consider when you're designing these battery packs, and he's going to give us an example of one of the Excell Criterion IQ battery packs that is driving towards addressing a lot of what I've discussed. Thanks, Mike.